talking? Let's see. Make sure I share it. Yeah. Okay. All righty. Okay.
You're good, Mr. Grolak. We can hear you and we can see your screen.
What's that?
We can hear you and see your screen. You're good.
You say we're good? Okay, gotcha. All right, thank you. All right, so using piecewise LSRLs, least squares regression lines. Okay. So here's our situation. We're running a business. We make fishing rods. Okay, and here's a report at the end of the year to show to his stakeholders. Okay, the table included in his report shows the number of rods made, so that's X. And then the cost of production, that was Y. All right, and then it says show this data on a scatter plot. Okay, that's already done. Okay, so I went ahead and I plotted the data on here. Okay, the X value is the number of fishing rods. And the Y data is the cost of production. All right, then it says use your calculator to find the least square regression line and sketch it on here. All right, so we're going to take that data and put it in for L1 and L2. So we'll make the rods L1 and the cost L2. All right, so let's do that. Okay, so let's see. Here, stat, edit. Okay, we're going to type those guys in. Okay. Okay, so now what we're going to do is stat, calc, linear regression. Now make sure your X list is L1, so I got to change mine. My Y list L2 in this case. And then I'm going to store my equation in Y1. Variable, Y variable, Y1. Okay, and now calculate. right, so I can see on this that my equation would be 2.9x plus 44.1. Okay, and now to see what that looks like, okay, make sure you got your stat plot turned on. And I'm going to use L1 and L2. Okay, so it's on. I pick scatter plot, L1, L2, check. Okay. I'm going to use those little squares, and then I go zoom 9. Okay, and there's my graph. All right, so now to plot this thing up here, okay, well, we can use this point, so 0, 44.1, so let's see if that's 50. I'm going to guess like 44 is maybe there. Okay, now I need another point that's on this line. So to do that, I just hit the trace button. Okay, now right now it's tracing the data points. It's just skipping through the data points. So I'm going to go up arrow, and now it's on the line. Let's see. I have mine in Y1. Okay, so I want to be sure that now I'm just going to find a set of points on there that I could easily graph. Okay, 60 to 25. That just gives me a rough idea of where to put a second point. Okay, so 60 to 25, 60 to 25, oh, about there. Okay, and now I can draw my line. Okay. All right, now it says comment. How well does it fit the data? Well, what do you look for on here to tell you how well something fits? How good of a fit is that? Good fit, bad fit, strong, medium, weak? Pretty strong because the R value. It's not bad R value. Okay, so this is not a bad fit at all. Okay, since R is around 0.969, the LSRL is a good fit. And we could make fairly accurate predictions for numbers that are in our domain. So what that means is for numbers between 0 and 100 rods, we could make good predictions. Anything over 100 rods, we would be making predictions that might not be as accurate. X is the number of rods. So as long as you're making a prediction for the number of rods between 0 and 100, this line would be pretty decent. So using it to make a prediction of 500 rods, not good. All right, Robin found that to make more than 50 rods a day, he had to use 2 machines rather than 1. Okay, use technology to find one regression line for 0 to 50 and another one for 50 to 100. Plot the piecewise regression lines on the scatter diagram. All right, so now instead of having one, we're going to have one that's going to fit 0 to 50, and then a second one that fits 50 to 100. Okay. All right, so let's make these. Here's our original scatter plot, same as the one above. Okay, and now what we're going to do is we're going to create a piecewise function. So we're going to write it like this. Okay. Okay, so f of x equals parentheses okay, so the first one is going to be when x is between 0 and 50. So we'll have that one include 50, and then we're going to have a second equation that goes from 50 to 100. Okay, so notice I didn't put, this doesn't have an equals on it. 50 is under the first one. Okay, now basically what this means is you're going to take this table up here and you're going to split it. Okay? So from 0 to 50, all right, the data that you're going to put in is going to be this up to 50. So you're going to make your L1 and your L2 these numbers. Okay, so X, Y, so I'm going to use 10, 100, 20, 120, 30, 140, 40, 144, 50, 155. Okay, and I'm going to make the X L1 and the Y L2. Okay, now over here, when the number of rods is more than 50, we got to switch machines. Okay, now you're going to make L3 and L4 the second half of this. So 60, 195, 70, 250, 275, 90, 340, and 100, 360. Okay. This one, let's store in Y1. And this one will store in Y2. All right. All right, so the first lists are okay. I just got to get rid of these past 60. So let's see, delete. Okay, so there's my first list. And then over here, I'm going to put the second half of that. So my 60, 70, 80, 90, 100. Okay, and let's see, 195, 250, 275, 340, 360. All right. Stat, Calc, linear regression, and this is going to be for the first one, L1, L2, and I'm going to store this in Y1. Okay, so that's what I get for my first line here. Okay, and this one's got an R value that's even better, 0.971. Okay, now we'll do the same thing for the second one. Okay, so let's see. Yeah, well, if I want to graph that, let's graph it. So I'm going to go second stat plot. Okay, this one is using L1 and L2. All right, so that's turned on. And it's going to be using Y1. Yep, I want to get rid of this guy. Okay, so I'm going to go zoom 9. Okay, that's what that graph looks like. Okay, so if I was going to sketch that, let's see, its y-intercept is 91, so I'm guessing about there. And then I'm just going to use the trace key to get a second point. Trace, up arrow, so I'm on Y1, and 131. Okay, let's see. I just need a second point. 140. Let's see if I can get something up around. Okay, so like 44 and 150 roughly. Okay, 44 around there. 150. I'm going to guess about here. So that just kind of gives me an idea of how to draw this line. Okay, so this is going to be my green line. And it's going to go all the way to 50. And it's going to have a solid dot on it. All right, now, when you do the second one, guys, okay, so I'm going to go, let's see, Stat, Calc. Okay, now I want to use lists L3 and L4. So I'm going to go second, L3, second, L4, and I'm going to store this one under Y2. Okay, and calculate. All right, and that's a really good fit. Okay, so this guy is going to look like Y equals 4.2 X minus 52. And it's got an R value of 0.988. Okay, now to plot that on your graph, on the same graph, watch what you got to do. All right, you're going to go second stat plot, and you're going to plot it under number 2. So we're going to turn plot 2 on, and we're going to make this L3, L4. So I'm going to go down here, choose that. I'm going to turn it on, make it a scatter plot, and now make these L3, L4, and I'm going to use a different symbol for the points, like this little plus sign. Okay, and now I'm going to go zoom 9. So there's our first one, and there's our second one. Now the only thing that we'll do that's different, this part won't be graphed, and this part we don't graph. Okay, so just to get a rough idea, some points that we can use. I'm going to go trace. Okay. 2, that's Y1, that's the first equation that we did. And now it's on Y2. So like 55, 179 would be a point. Okay, I could just kind of play around 60, 200 roughly. So like 60, 200. Okay, and that's going to go through here. Okay, so this was Y equals 1.34 plus 91.6. And this one was Y equals 4.2 x minus 52. And you can see now this makes my chart even more accurate, because these lines are better fit than the previous lines. So the whole point of this is I can make more accurate predictions using this. Okay, so let's see. Up here, this is y equals 1.34 x plus 91.6. And this guy is, oh, you don't need to write the y equals. Okay, we know it's there. That's what f of x does. So this is going to be 1.34 x plus 91.6. And this guy is 4.2 x minus 52. So if you're making any predictions between 50 and 100, you'd use this bottom predictor. Between 0 and 50, you'd use the top predictor, and you'd have more accurate answers because these coefficients are better than the 0.96. Okay. All right, guys, that's the last of our chapter. So for tomorrow, you're going to do these 4 graphs. That's what we did yesterday. And then you got 2 questions doing what we just did today. Okay, that one and this one. And then we'll check that tomorrow. Okay, let's see, Alt.